Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we have started the chapter Transaction Management. In Transaction Management, in the last session, we have discussed what is a transaction, what are the properties of the transaction, and what are the states of the transaction. In today's session, we are going to discuss about recovery management. Whenever there is a failure of transactions, how to recover from that situation. So we discuss some schemes which are responsible for recovery management in transactions. Let us start the session. Recovery management. What are the schemes in recovery management? Recovery management is mainly responsible for atomicity, durability. What is atomicity, sir? Every transaction should be completed either 0% or 100%. That is the main one. It should not be stopped or stuck in between 0% to 100%. What is durability? The data must be permanently saved. I should not lost any data under any circumstance. We should not lost the data under any circumstance, whatever the reason may be. So these are the two properties of transactions, and recovery management is responsible for these two properties. What are the schemes under recovery management? The first one is shadow database. The second one is log based recovery. So recovery which is based on logs. Under log based recovery, we are having mainly two types of schemes. The first one is deferred DB modification. The second one is immediate DB modification. Let us discuss each of these schemes one by one. What is shadow database? Okay, let me explain. Let us suppose this is our hard disk or some stable storage. This is our hard disk or some stable storage in which we have our database. So this is the stable storage. Let us assume this is my database. Then for this database, we have a starting address. That starting address, let us suppose we save in a variable P. So it will point to the starting address of the database. This is the situation of the database before we start the transaction. Now, let us assume this is our main memory or RAM in our system. Whenever we want to do the modification, the first step is I need to bring the entire database to the RAM. The entire database, sir. So we bring the entire database to the RAM. So this is the database copying. The second step is, first step is bring the entire database. The second step is we update the database in RAM, not in hard disk, sir, because the updations can be done in RAM only. So update the database in RAM. That is our second step. So the second step will be done here itself. Now the third step. Save this database to some location in the hard disk. We don't touch the original database in the stable storage. So we are storing this fresh or updated database. Save the updated database. save the updated database in hard disk. Now our updated database is this one, sir. So this pointer should point to the updated database. So what should I do, sir? I need to update the pointer P. I need to update the pointer P. So it will point to the updated database. This is the procedure. Suppose there is a failure. There is a failure. When we are in the stages 1, 2, 3, then there is no loss. The data in the RAM will be crashed, but the original database will be in the hard disk, which is safe. So we have the original database. That means we done 0% of transactions. Right, sir? The only possibility to failure this scheme is, suppose we saved this database and we are updating this pointer to this one. Okay. Sorry, sir. Yeah, fine. So whenever there is a failure among these steps, the original database is here itself. Suppose there is a failure at the 4th stage. That means we are updating the pointer linked to this one. If this successfully done, we point to the original database. If this successfully not done, we point to the old database. So in any case, we don't lose the database. If we can complete the 4th step, then we will point to the new database. If we cannot complete, we point to the original database. Okay, that is the shadow database scheme. What is the main advantage, sir? It is very easy to implement. It's very easy to implement. Am I right, sir? There is no confusion. We are updating the database and we are saving somewhere else. If everything goes smoothly, we update the pointer. That's it. What is the main disadvantage? Suppose the database is very large. Every time whenever I want to do a small transaction in a particular relation, I want to bring the entire database. Why to bring the entire database, sir? Suppose I want to modify some data about Tamil Nadu Express. To do that particular transaction, I need to bring the entire database of railway reservation system. Is it meaningful, sir? No. So this is not suitable for large databases. This is not suitable for large database. Hope you understood it. So this is about shadow database scheme. Now let us move to the next one. Log based recovery. This can be applicable for small databases as well as large databases. Okay. So let us start it. What is log based recovery? Sir, what is log? In simple English, to understand it, it is a rough paper. It is a rough paper. That's it. Okay. Log records for every operation. Log records for every operation of a transaction are recorded. What does it mean? Let us assume DBMS is original page. DBMS is original page. Actually, in this page, I want to do the modification. But before doing the modification in the original page, what I do is I will verify whether I am able to complete the story or not. That we do in a rough paper. This is called log file. So first I do all the modifications or all the work in this rough paper. If everything goes smoothly, then I start working on the database. Okay. The best example is, suppose whenever you are taking a class, suppose if it is the first time, what you do, sir? You don't try directly on the blackboard. We don't try directly on the blackboard. So blackboard is the original page. where I want to do my transactions. So before going to the class, what the faculty will do, sir? They will verify on a piece of paper. They will verify on a piece of paper the work. If everything goes smoothly, then they will start work on the blackboard. That's it. So this is called log file. Where you are doing experiment, that is log file. If something unexpected happens, there is no problem because it is rough work or no one is seeing about it. So we don't have any loss, right? That is the story of log records. Now there are mainly two types in log based recovery. Sorry, sir. So log records are maintained on a stable storage. What does it mean? I will do the transactions on the rough paper. Once I done or once the transaction was done completely, I will save that paper in a stable storage because I want to make a review of it. Whenever I got some doubt on the blackboard, I need to have a copy so that I can verify what I need to do. Then I will start on the blackboard. Right? So let me give the example, sir. This is our RAM. This is our database, or first of all, let us assume this is our hard disk. We bring the page whatever we need to the RAM. We bring the page whatever we need. So this is our original page. Here I want to do the modification. Before doing the modification, I will create a temporary file. I will create a temporary file which is log. I start the transaction, that is the operations of the transaction on the log file. Once I feel it was done completely, I save this log file to the permanent storage. So this is the log file. Then I start working on this page. So I will start the operations on this one. This is the general scenario how the log based recovery works. Now let us discuss the two types of schemas in log based recovery and what are the main differences between those two schemes. Coming to the first one, deferred database modification. What is deferred database modification? Sir, as we told, this is the RAM. This is the hard disk. Okay, this is my database. Now I want to do some modification. So we bring that page to the RAM, right? And I will create a rough paper log file. I start the transactions 1, 2, 3 like that. Okay. If the transaction was completed successfully, suppose our transaction contains 100 instructions. Our transaction contains 100 instructions. Then I complete all the 100 instructions in this place. Okay. Maybe it may need one more log file. Okay. But if I cannot complete all the 100 operations, I don't start working on the main page. I don't start on the working on the main page. So the first step is complete all operations of transaction. All operations on log file. That is the first step. So when you are able to complete all the operations, you will get some confidence. Yes, I can complete this transaction. Then the second step is save these log files. Save these log files in hard disk. Save log files. Okay. So before that, suppose this is the next one, last log file in which I completed all the 100 transactions. Then in the log file at the end, I will write commit to indicate I completed all the operations. How should I know, sir? How should I know there are 100 operations or 10 operations? I don't know, right? So whenever I am able to complete all the operations of a transaction, we will write commit. So to indicate all, what we do, sir? We write commit working on the original page or database page. This is the story, sir, right? Suppose the transaction is very lengthy, so then I save log1 file, log2, log3, like that. Okay, sir, in this log1 I don't have any commit because the transaction was not completed, right? So that means whenever there is a log file, if there is no commit, what does it mean, sir? Transaction not completed. Transaction not completed. Not completed means it was not started originally on the database. So it not started on the original database. It not started on DB page. Am I clear, sir? Suppose there is a commit. Suppose there is a commit in some log file. What does it mean? We might start. So we might start the original database. Because in deferred we delay the modification on the original. Right? Now the question is, suppose there is a failure, sir. Suppose there is a failure. Then the first step is go to log file. Verify for commit. If commit is there, what should I do? If commit is not there, what should I do? First, let us discuss the second case. Sir, assume there is no commit on the log file. What does it mean, sir? The transaction was not completed. Still, I am doing on the rough papers. Then do you need to worry, sir? No. The original database is safe in its location. We not started, we not updated. Because I not completed my work in rough paper. So we are safe. So no need to do anything. No need to do anything. Suppose there is a commit. What does it mean, sir? We might started the work. We might started. We don't know whether it is completed or not. Then what I do is start from beginning. Start from beginning. That is redo it. That's it. Hope you understood it. We verify the log files. If there is a commit, that means we might started. So I will start from beginning. That is, I will redo it. Suppose there is no commit. Surely we not started in the original database. If we not started in the original database, why to worry? Just forget about it. Right? So that is deferred database modification. So we defer all the rights to after partially commit. Sir, what is why we written partially commit means we completed the transaction in rough paper, not in the original paper, right? Every log is of the form. What does it mean? Write operation. What is the transaction number? What is the data object? What is the new value? Suppose there is a transaction T10. It is modifying a variable A. Suppose this is I am having 100. Now T10 is modifying this 100 to 200. Then we will write like this. Every write operation. I am writing the operation right. Who is doing, sir? T10. On which it is doing, sir? A. And what is the new value, sir? 200. We don't store the old value because we are not undoing any operation. Just we are redoing it. Whenever you are redoing or whenever you are restarting, I need only the new value. I don't need the old value. So that's why here we are not storing the old value of X in this log. After T partially commits, Commit is recorded in the log. Commit is recorded in the log. So the log file is ready completely. Then save it to the stable storage. Yes, done. Then start on the original database. Start the writes on the original database. Hope you understood it. Once you complete all the transactions, write the log file to stable storage, then start working on the database, right? Whenever a transaction crashes, suppose there is a failure, then we verify for commit. If commit found, what does it mean, sir? We might started. Since we started, I need to start from the beginning because I don't know where I was stuck or where I was failed. That may be 20%, that may be 30%, that may be 100%. So we start from beginning. So redo all the operations. That's it. Redos must be done in the order of serial transactions. Sir, this is the main important, sir. Whenever I want to redo, suppose I have some transactions T4, T10, T8, in which again I have some two operations. Here I am having 3 operations. Here I am having some 2 operations. I need to start from the beginning, sir. That means first I need to start T4. Even in T4 also, I need to start the first operation, then the second operation, then go to that one. So that means I need to do the operations in the same sequential order, whatever we are having initially, whenever we are doing redo. Redos must be idempotent. Redos must be idempotent. What does it mean? Suppose there are 2 transactions. T10 is modifying the value of X to 200. There is one more operation. It is also doing the same story. Then you can apply the redo operation only for one time, because even if you write for 2 times, what is the meaning, sir? The result will be, we will store the value of 200 in X. That is the meaning of idempotent. Hope you know what is idempotent, right? Suppose commit is not found. Commit is not found. Whenever commit is not found, we not started. When not started, why to worry, sir? Forget about it. Again start, take care of paper, again start it. That's it. So no need to do anything. Just be calm or ignore it. Hope you understood deferred. Sir, because until we don't complete the entire problem on white paper, I don't start on the blackboard. Whenever I not completed on the rough paper, why to worry? Because I not started in the blackboard. Whenever you start in the blackboard, you need to finish it. So that is the main story. Deferred modification is also called no undo, because we are not doing any undo operation. We are doing only redo operations. So that's why we can also call it as no undo and redo operations. Sorry, no undo and redo recovery scheme. The quite opposite, immediate database modification. In immediate database modification, it don't wait, sir. It don't wait. Suppose I completed first log file. This is the original database page. This is my hard disk. Suppose I have some 10 transactions, but I completed only 3. Then I don't wait till the completion of 10 transactions. Save this here. 1, 2, 3. Write those 3 operations on database page. Again, take second log file. Complete 4, 5, 6. Again, save this to stable storage. Again, do the operations 4, 5, 6 on the database. Again, continue like that. So for every log file, even we don't complete all the operations, we start doing on the modification on the original database. Hope you understood it. Now the story is, what is the problem? Suppose crash occurs. So we verify the same story, commit. So let us assume there is no commit. What will happen? Or let us assume there is a commit. Sir, we are always verifying this commit or no commit in log files only, because we should know whether we started on the original database or not, right? Suppose there is no commit, then can you give guarantee that you not started the work? No, right? Because even I not completed all the 10 operations, I started 3, right? Totally there are 10 operations, but I have written only 6. Still, I done the modification in the original. So whenever there is no commit, you cannot say you not started. You already started. But there is a failure. What should you do, sir? Again, you need to start from the beginning. But to start from the beginning, first of all, I need to undo these operations because they have done some modification. They have done some modification. So first I need to undo all those things. Something like I have done some 6 steps on the whiteboard. I not completed on the white paper, but I started on the whiteboard. So I completed 6 operations. Suddenly I felt it was crashed. Then what should I do, sir? First I need to rough all the 6 lines. So that means I need to undo the operations because I need to go back to the initial stage. That is the main story. So first I need to undo the operations. Hope you understood. Then again I need to start from the beginning. Suppose there is a commit. Suppose there is a commit. It was done, and even it was done in the original databases also. Then we will redo. We will redo the operations. So for every transaction, if there is no commit, I will undo. If there is commit, I will redo. That's it. Previously, whenever there is no commit, we forget about it. Allows rights to modify the database even for uncommitted transactions. So even it was uncommitted, we might start. We may complete some 50% to the original database. Write log form is something like the transaction number. Suppose transaction 10 is modifying an object A whose initial value is 100. It is modifying to 200. Then I need the transaction number and the object name and the old value and the new value. Why old value and new value, sir? The old value we need whenever I want to do undo. Suppose I already modified A value to 200. I want to redo. Sorry, I want to undo. Something like I want to do Control Z. Then what should I know, sir? I should know what is the old value of the variable. So that's why I need this old value. For some transactions, I may need redo. So I need to know the new value. So that's why in this type of scheme, we store the old value as well as the new value. Hope you understood it. This is the transaction number. This is the object. This is the old value. This is the new value. Log record of write must be written to stable storage before the corresponding write is performed on the database. This is what we told, sir. Before I am doing this 1, 2, 3, first I will save this log file in the hard disk. Whether you complete or not, whatever is that work you done, that log file should be saved in the hard disk. Then only you should start work on the original database page. Whenever a transaction crashes, its commit is verified in log records. This is the main story, sir. Always we verify commit in log records. If found, what does it mean, sir? It was started and it might be completed also. I don't know. So that's why we do redo. Simply, we will do redo. Redo all operations. Okay. Redos must be done in the serial transactions. I told you, sir, whenever you want to do, I need to do the transactions from begin to end. Redos must be idempotent. So even there is an operation for 2 times, we will do for only 1 time. Suppose no commit. Sir, when no commit, we might be stuck in middle. So first I need to undo. I need to undo whatever the actions they have done. I need to undo. Undo all operations. Now listen to me, sir. Undos must be done in the reverse order of serial transaction. This is very important, sir. Suppose T4, which is having 1, 2, 3 operation. Suppose there is some T2, which is having some 2 operations. So this is the order we done and we failed. Then I need to undo in this direction. That means I need to start T2. Even in T2 also, what is the first operation? Second operation. Then first operation. Then I will start T4. I will do in reverse order. Hope you understood it. For redo, same serial order. For undo, complete reverse order. Transactions in reverse order. Even the operations also in reverse order. Even undos also must be idempotent. That means if there is a operation for 2 or 3 times, we do for only 1 time. Here you are doing 2 things, sir. Okay. Before going to this one, listen to me. All the undos must be done before any redo. Suppose I have T10, which I need to do redo. I have T4, T2, which I want to do undo. We don't mind which was started first. First I need to complete undo list. Then I need to go to redo list. So all the undos must be done before any redo. This scheme is called undo or redo because we are doing both operations. This is the story about log-based recovery. Let us discuss some examples and previous problems based on these 2 schemes. Okay. So this is the first question, sir. What is the effect of undo operation? Whenever you are doing undo operation, what does that mean, sir? I need to store the old value. Okay. Instead of store, if you write restore, it sounds good, right? So of course we are doing it, sir. So we need to restore the old value. That's it. Now I have a transaction number Ti. X is the data item, S is the old value, K is the new value. So they given this is the transaction number, this is the item, this is old value, this is new value. Sir, I need to know only the old value. This is the new value. Whenever you are undoing, you don't need the new value. So what should I do, sir? In X variable, whatever the value may be, my job is I need to restore the value of S. That's it. So no changes to X. It was not correct. Write the value of S to X. S, right? Because we are writing the old value to the variable X. Hope you understood it. Let us do one more question. Consider the following log sequence. T0 started, sir. Okay, A, old value, new value. Please observe it. Here they given clearly. This is my old value. This is my new value. What does it mean, sir? It is immediate database modification. Of course, they given also. Right? So T0 started and done some 2 transactions, 2 operations, and it was committed. T1 started but not committed. What will be the action? Okay, this one directly you can do it here, sir. T0. For this, do we have commit? Yes, I have commit. Yes. Whenever it is yes, what should I do, sir? Redo. So redo T0. That's it. For T1, is there any commit, sir? No commit. Since no commit, what should I do, sir? I need to undo T1. So I need to do 2 tasks. Undo T1, redo T0. Which I need to do first, sir? I should not start T0 since it was started first. First I need to complete undo T1. This is my first course of action. Then followed by I need to redo T0. Because all the undos must be done before redos. So what is the answer, sir? Undo T1. One minute, sir. Immediate, right? whenever there is no commit, I need to undo, right? Undo T1, redo T0. Undo. Sir, 1 minute, sir. I think the options were given wrongly, sir. So it should be like this. Undo T1, redo T0. It might be printing mistake, sir. That's it. Okay. Suppose they not given any options like this. Then here if you observe it, we have redo T0, undo T1. This is also correct, but they given in reverse order, sir. Suppose if there is no option like undo T1, redo T0, then we go for this option. Okay. But in general, if you are speaking strictly, first I need to complete undo, then only I need to go for redo. This is the list of actions, fine, but it is not the sequence. Whenever it is list, the list is correct, but it is not in the order. Let us go to one more. 1 minute, sir. Fine. Consider the following sequence of log records in the log file before system crashed. Fine. T1 started. Fine. It done some operations and it was committed. T2 started. It was not committed. So only two things, sir. T1 started, committed. Commit. Yes. So what you should do, sir? You need to redo. T2. Is it committed, sir? No. It was not committed. Since it was not committed, what you need to do, sir? Undo. This is the story. Now let me write the list. First I need to undo T2. Even in this also, the operation should be from the back to first. What is T2, sir? In T2 there are two operations. This is my first operation. This is my second operation. So first I need to do the second operation. That is undo, right? Whenever you are doing undo, what should I do, sir? For A, I need to store the old value. What is the old value? 4. Because the transaction is A48. Always the first one is the old value. It is undo. Then I need to go for the first operation. What is that? For B, I need to store back 2. So this is the first step. What is the second step? I want to redo T1. For redo, what should do, sir? You need to do from beginning. So for redo, we have two operations. This is the first one, this is the second one. So the first operation is A. Here I need to save the new value. What is the equation they given, sir? W1 of A3, 4. So here I need to write new value. What is the second one? For B, I need to write the new value. That's it. So now what is the option which is matching, sir? First undo T2. Fine. A equal to 4, B equal to 2. Redo T1. A equal to 4, B equal to 2. Yes, of course, it is direct correct. Here please observe it. First they are doing redo. Second they are doing redo. Both are not redo, sir. So it's not correct. First is redo, second is undo. Sir, these two are same. But undo first, sir. A comma B both are having same actions. But undo first. So that's why we choose an A. Hope you understood it. Now, what are the problems with logs? Suppose my transaction is having almost some 200 operations. Then the log files become very lengthy. So the logs become very big when we are having so many operations in the transactions. So searching in log files, because whenever the log files are very lengthy, for every operation transaction, I am searching for commit in the log files. So which is a very costly. And transactions may be redone unnecessarily. Sir, suppose I have almost some 10 operations, 10 transactions. Among all these are committed. All these are committed and I already completed. T10 it was not completed, sir. Not commit. It is very lengthy. So I am doing. Crash occurs. Then I need to do all the 9 and 10. So for all these I need to do redo. For all these T9 I need to do redo. Why to redo again, sir? Because they were already completed successfully. Okay. Suppose we started redo and again we are doing T10. Because of length in T10, sometimes there is a more chance of failure. Right. So again I need to redo. That's the meaning of it. Instead of that one, we can make some tick mark. There is no problem up to T9. If you make a tick mark, I can understand. Okay, fine. Even there is a crash, I need to consider only T10 only. No need to consider T9. So that tick mark is called checkpoint. So that tick mark is called checkpoint. That means whenever my list of actions is very lengthy, here I will make a tick mark. So here I will write some transactions which I suppose to consider. These are the two things I need to keep in mind. All the remaining are done. Similarly, suppose after some time again I will make a tick mark. T10 completed, only T11 is left. If some crash occurs, I will consider only this T11. No need to consider the remaining because they were done safely. So that is the meaning of checkpoint. So in checkpoint, what you need to specify? To write a checkpoint, well, first of all, what should I do? To make a tick mark, what should I do? Log records must be flushed to stable storage. So this is like this, sir. Whenever I feel up to here it is correct, this I write to hard disk. This is my hard disk. First we write this log file. That is the first step. All pending writes to be done in the database. So this is the DB page, write 1, 2, 3, so on. Then entry checkpoint L. What is the list, sir? In this we write what we write in this list. A list of transactions which are active at this point of commit. Sir, at this point of commit, suppose T1, T4 completed. Only T3, T2, T5. These are need to be completed. Then in that list I will write it. Because whenever there is a crash occurs after this point, no need to consider T1, T4 because they were done. So I will consider only this list. So the list of transactions which are not committed by the time of checkpoint. Hope you understood it. Now, how to verify or how to identify what are the redo list, what is the undo list? When a crash occurs, the first point, no need to consider any line before tick mark because all these were done successfully. Even suppose T5 is not completed, but some operations were done for T5. These operations no need to touch. The remaining operations may be touched, sir, because they were not completed, but up to here they are fine. So only the operations after checkpoint need to be redone or undone because up to there it was fine. That means they were done to the database. If commit is found, sir, commit is found where? Before checkpoint, after checkpoint. Here is a checkpoint. 1 minute. This is my checkpoint. Suppose commit is found here. Commit T4. What does it mean, sir? T4 successfully completed before checkpoint. Forget it. Suppose commit is found here. It was not completed before checkpoint. So what I need to do? I need to do all these operations redo. The same story we do, sir. Whenever there is a commit, it is redo only. Whenever there is no commit, undo only. But we consider the operations after checkpoint. No need to touch the operations before checkpoint. Suppose it was committed before checkpoint, that means it was done completely. So after checkpoint, redo it. Redo also, redo operations which are after checkpoint. Something like I decided T4 need to be redone. T4 need to be redone. But for that, 3 operations are before checkpoint. Some 2 operations are after checkpoint. So I need to consider only these 2 operations. No need to consider these 3. Before checkpoint, just forget about it because it was completed before checkpoint, everything is fine. If commit is not found, if commit is not found means it was not completed. Whenever it was not completed, what you do, sir? You need to undo it. You need to undo. Even these operations also, operations only after checkpoint. Whether you redo or undo, because up to right mark everything is clear, sir. That is the meaning of right mark. Okay. Let us consider one question on this. Consider the following log file created a basic checkpointing recovery protocol environment. So the same questions are, we have checkpoints. Whenever we have a checkpoint, forget about the operations before checkpoint. That's it. So they started T1. Let me write it, sir. They started T1. Okay. They written one operation, then started T2. For T1, A2, 3. For T2, B4, 5. Then again T1, B5, 6. Then T3 started. Okay, let me write in boxes. This is the first one. This is the second operation of that one. For T3, it started. Then it was committed, sir. Then T3, it has done the action of A36. Then checkpoint. So this is the checkpoint. Up to here everything is fine. Then T4 was started. T4, it started the first operation on A6, 7. Here it was started. Then T3, it have one more A7, 9. Then T4, it is having B6, 7. Then T4 completed. I think better to write in next slide. Okay, let me write it here, sir. It was completed. Fine. Anything else? T5 also started. I think better to write in next slide, sir. Let me write it again. I am redoing the operations, right? T1. Since I cannot complete all the transactions, I am again redoing the story, sir. T1, it was started. It modified A from 2 to 3. Then T2 was started. It returned B4, 5. T3, it was started, sir. Then it returned T1 B5, 6. Then for T3, we have an operation A3, 6. Then there is a checkpoint. Okay, and here they mentioned clearly, observe it, sir. T3, T2. Because T1 already committed, I think, right? I think T1 committed, sir. T1 committed, right? So in checkpoint, they mentioned T3, T2. Sir, please observe it. Whether you redo or undo, you don't consider T1 because it was successfully done before checkpoint. Now T4 started, sir. You started T4. What is the first operation of T4? A6, 7. Then T3 you have A7, 9. For T4 you have again B6, 7. Again you started T5. For T5 you written A9, 4. Right? Fine. No need of this T1, sir. Any commit, sir? For T4 I have a commit. Anything else? No, sir. So for T2 no commit. For T3 no commit. For T4 I have a commit, sir. For T5 no commit. Sir, first write undo. What we do undo, sir? For no commit. So no commit I have undo list. What is the undo list? Totally T2, T3, T5. Even this also we need to do in reverse order. So first T5. What is the action of T5? A2 old value. A2 old value means the old value is 9. Then we started T3. What are the operations of T3, sir? A2 old value 7. Then T2. Do you have any operations after checkpoint? No. So no operations. Then I need to start redo. I have only one thing. What is that? T4. What are the operations for redo? Same order. A2 new value. Then B2 new value. Hope you got it. So that is the story about this one, sir. Now let us verify the option. So T5, sir, first one. First I need undo. Here I have undo, here I have undo. First I will have T5. Yes. T5 A2 old value. It's fine. Then T4. But I think T4 is committed, right? It's not correct. It's not in undo list. T4 is in redo list. Please verify it. T5 A9. T3 A7. T2 no operation because there is no operation after checkpoint. For redo, first operation followed by second operation. Hope you understood it. Let us do one more question, sir. The same, sir. T1 started and it written A 1200 2000. It was committed. Checkpoint. Oh, only with 1 point checkpoint, right? Fine. Then T2 started. But T2 started after checkpoint. It written B 1500 to 1800. Then it started T3. It was also having after checkpoint A 1500. T4. It was also started after checkpoint. It written C 3000 to 4000. Then W3 is having one more operation D 3000 to 2000. Any commit, sir? This was committed. W2 I have one more operation A 500 1500. But no commit, that's it. So this is no commit, sir. This is also no commit. The first one we forget because it was committed before checkpoint. So what is undo list? Undo, I have two stories. One is T2, one is T4. If you write very strictly, first I need to complete T4, then I need to go for T2. If they ask list, you can write simply T2, T4. What is redo, sir? That is T3. Right? So undo T4, T2. Undo T4, T2. Sir, please observe. Redo list T1, it's not correct. Undo list T4, T2. Redo list, I should not have both. Undo list T2, T4. But it is not in order, sir. Redo list T3. Okay. At least this is somewhat correct because they are in undo list. They are not given the sequence, fine. Undo list T4, T2. Redo list T3. Yeah, please observe it. It is in correct order. T4, T2, then redo list. So if they ask list, B and D are correct, but this is more strong because even on undo list also they written in correct reverse order. Hope you understood it. Let's go to one more question. So they started T4, written T4, Y23, started T1, then committed T4, then T1 written Z57, checkpoint. Then it started T2, but T2 started after checkpoint. It written X19, then commit. So it was committed. You started T3. This was also started after checkpoint. You written Z72. Sir, if it was committed before checkpoint, forget it. For this, no commit. For this, no commit. So what is undo list? T1, T3. If you write very clearly, T3 followed by T1 because we need to do in reverse order. Then what is redo list? Redo list is only, I'm sorry sir, redo list is only T2. Right. So undo is T3, T1, redo is T2. This is correct. Undo T3, T1. Sir, we don't consider this T4 because it was committed before checkpoint. In undo, they written T4, sir. It's not correct. So the correct answer is A. Hope you understood it. Let us see one more previous question, sir. Suppose a database system crashes again while recovering. That means we got crash. Again you are doing recover. There is a crash. So you started recovering. Again it was a crash. Then assume checkpointing is not done by the database either during transactions or during recovery. So there is no checkpoint, sir. Then which of the following statements are correct? The same undo redo list will be used while recovering again. Sir, the same undo because there is no checkpoint, right? So the same list you can use for recovering. That's it. Something like, let me give a small example. Suppose you written some regular exam in BTech. We written some regular exams. You failed. Then you asked your faculty what should study, what should not study. That means what should I should not keep in my mind, unnecessary things. Okay. So what to do, what not to do. So the list you already got. Again you written for second time. This is for first time. Second time you written supply. Again you are failed. then we don't go to faculty again, sir. We will use the same list, right? Because faculty don't give, right? So the same undo redo list will be used while recovering again. Hope you understood it. Because that is the list I need to follow to recover it. Either it is first time or second time or 10th time. That's it. So this is about recovery management in transactions. In next session, we will discuss about concurrency control protocols. Thank you.